Here we go. Question 10. A project brief requires blah, blah, blah. So, sound the temperature falls below 36 degrees, and they've drawn this for us. Thevenin's theorem is used to produce an equivalent circuit. This is a 5-mark question. Well, okay. So, Thevenin's theorem, the voltage is, remember we use this as like a ratios thing. So the ratio of these two voltages is 100 to, these two resistances, 100 to 180. That's 5 to 9. So the ratio is 5 to 9. That means that so that's a total of 14ths. So 5/14ths of the voltage is dropped across here, and 9/14ths here. So the V out is 9/14ths of the 12 volts, and I think that comes to 7.71. So 9/14ths of 12 volts. It's just basic ratio question. The short circuit current. Remember, short circuit, literally cut that out. What current flows through this bit? Well, we use V equals IR, and so it's 12 divided by 100, which is 0.12 amps. Okay, so we've used ratios to work out the open circuit voltage. We've used Ohm's law to work out the short circuit current. Remember, literally just cut this out, and what's the current in this bit of the circuit? Imagine that that's not there. And finally, then the equivalent resistance, again use V equals IR, is the voltage divided by the current that we've just worked out, and that comes to about 64.25 ohms, or 64.3 ohms if you wanted to round off. So 5 marks for that. That's not a bad 5 marks to get. Okay. Now we've got to draw the equivalent circuit. Well, that's pretty straightforward if you remember rightly. So we've got a voltage rail and a resistor, and we know that our voltage is 7.71, so we've got a ground down here, and our resistor is 64.3 ohms, and then that's it. Okay, so we've got terminals here and here, but our equivalent circuit will look like that. Okay.